All right, this is the demonstration of the phosphate lab procedure, lab 2, and I should mention before we start that this kind of a procedure is not just limited to phosphate analysis. Anything that's a colorimetric kind of analysis is will be done like this with different protocols, of course, but the same. I mean, with different chemistries, but the same kind of protocol. So we start out, and we have the first thing to do that in fact, what takes the longest time in this lab is to establish what's called a standard curve. And if you look in your lab protocol, what I mean here is on page 5, a relationship between the added concentration of the phosphate in this case and the absorbance of the phosphomolybdate complex that we're going to make in the spectrophotometer right here, okay? That's a standard curve. Now the easiest way to design it or develop a standard curve is the following. You have a volumetric flask. It's a 100 milliliter volumetric flask, okay? And here is a phosphate standard that contains 600 micromoles per liter. 600, it's the green. Now this will be kept in the refrigerator, and it must be kept in the refrigerator. The refrigerator will either be in this room, or if it's not in this room yet, it'll be next door in room 107 in my lab, okay? This is the gun pipette. Very old, they don't make them anymore, and but they're the best kind I've ever found. So you take the 600 micromolar phosphate, and the pipette tip that's in the little side arm on the bottle, and you just put it on the end of this black extender, just snug. Don't yank it on there. Just put it on there snug like that. Okay. Then you open up the volumetric pipette. Just lay the stopper down. Open up the 600 micromolar standard. Now make sure this is set on 1. So what you do is you rotate 1/4 of a turn to the right, let it out all the way, and then rotate it 1/4 turn to the left so that the last number you see there is 0.1. Then it's set on 1 milliliter. Okay? Did you see that? Okay, then you push the plunger all the way in, put the tip underneath the surface of the liquid, and let it up slowly like that. Don't just let your thumb slip off of the plunger. Then squirt that in the waste bucket. That's just to wash out the pipette tip. Then come get another milliliter and carefully put that right in the volumetric pipette. Okay? Then every time you change the tip, take the tip off, take some deionized water, just squirt a little bit of deionized water in there, let it drip out, and then put it back in the holster, and not drop it, put it back in the holster, cap the standard, and then you would get up and put that in the refrigerator, but I'm not going to do it, but that's what you do. Now you got 1 milliliter of the 600 micromolar standard. Now you take seawater from the boat basin from the jug that's behind me, just like you did in lab 1, and you carefully pour this in the volumetric pipette, and watch what you're doing, and pour it in until the liquid gets up to the bottom of the neck, right where my finger is. Okay. Now you want to fill it precisely to that etched line. Okay. So then you take a pipette, rinse it out once with water from the boat basin, and then carefully drip it in until it gets, now I've got to raise it, right, the meniscus gets right to the bottom of that, the bottom of the meniscus is right on the line. Okay? All right, now what you've done is you've diluted 1 milliliter of 600 into 100, so the concentration in here is 6 micromolar. Now you invert it a few times to make sure it's mixed. Okay, and now you're ready to make up your standard curve. So now what you have is you have the 6 micromolar standard, and you have the seawater from the basin that has 0 added phosphate. Now you take a pipette tip, put it on here, and follow the protocol that's on the second page of your handout, and that is right, okay, here, where there's this little table that it says seawater milliliters, substandard milliliters concentration. Okay, now the seawater is the stuff in the beaker that you've just poured directly out of that jug behind me. The substandard is the liquid in the volumetric flask. So now what you do is you have these little vials. You see the little vials here, and they're lined up. Now they'll be in this box right here when you come in, but the first thing you do when you come in, after you turn on the spectrophotometer, by the way, is line these things up. So you've got 3 zeros, you've got 2 that say 1.2, 2 that say 1.4 right behind each other, 2 that say 3.6, 4.8, 6. Okay? So you take your pipette tip, and the first thing you do is you take your basin seawater just out of the beaker, and you follow this protocol. The ones that say 0, the 3 vials that say 0, get 5 milliliters of seawater. The ones that say 1.2 get 4 milliliters of seawater and 1 milliliter of the substandard. The ones that say 2.4 get 3 milliliters of the seawater from the beaker and 2 milliliters of the water from the volumetric. See how it works? So what you do, and now I'm not going to go through this whole procedure, you push the plunger in, let it up slowly. Now, 1, 2, 3, 4, 5. Okay, now you do that to the other 2 vials marked 0. Okay, but I'm going to go to now the 1.2. To the 1.2, you put 4 milliliters in. 1, 2, 3, 4, and then you would repeat that in the other 1.2 vial. For the 2.4, you put in 3 milliliters of the seawater from the beaker. 1, 2, 3. See how it works? 3.6 gets 2 squirts. 1, 2. The 4.8 gets 1. And the vials labeled 6 get 0 from the beaker. Okay? Then with the same tip, since it's real well washed out, take your substandard. The zeros get nothing. The zeros are all set. They have 5 milliliters already. The 1.2s get 4. I mean, get 1, right? Because they are going to have 5 in the final analysis. The 2.4 vials get 2 squirts. 1, 2, and the 3.6 get 1 squirt. I mean 2 squirts. The 4.8 get 1, and the 6.0 4, and the 6 get 5. And you just follow this procedure because they're all going to have 5 milliliters total at the final analysis. Okay. Now once you get them all filled, then there's another big bottle in the refrigerator labeled unknown, and I forgot to get it out, but it's a big bottle and it will be in the refrigerator labeled unknown. Put 5 milliliters from that in each one of these 3 vials labeled unknown. Okay? So now you've got all your vials filled and everything is ready to go. Now you take the pipette and set it on 0.5 milliliters. And for that, you push the you turn the handle until the numbers are facing upwards, and then you push it in until 5 is the last number you see, and rotate it quarter turn right, so it looks like that, okay? Then you take this bottle that says phosphate mixed reagent, and this is in the refrigerator as well. This will go bad if you leave it out overnight. If you leave it out overnight, it will turn black. If it's black, it's no good. So you have to get this from the refrigerator and immediately put it back in the refrigerator after you've used it. It says phosphate mixed reagent. If it's good if it looks kind of canary yellow. And I just made this up, so this is good. So you take the cap off, of course, and you put the pipette tip that's in the little holster on the side, and you put a half a milliliter of the mixed reagent in each one of your vials. It's the same amount, just 0.5 in each one of them, and you go ahead and do the whole series. Okay? Then it's most important, when you're done with the mixed reagent, cap it, get up, and put it in the refrigerator. I'm not going to do that, but do that, okay? Then you wait 15 minutes, and the things are ready to read in the spectrophotometer. All right, so now I have some that I've waited 15 minutes on, so I'll slide over here. And this is the Genway 6320D spectrophotometer, okay? And it's very easy. And the first thing you do when you come into the lab is turn it on with a switch right above the power cord in the back. I've already done that, okay? You open the chamber, and you get a look in the chamber here now. You see two cuvette holders, the one closest to the center, and then there's one over to the right. You use the one in the center. Now this is a plastic spectrophotometer cuvette. They're made of plastic. They have two sides that are clear, that you're looking through the clear side now, and two sides are frosted, like that, okay? Now you can touch the cuvette all you want on the frosted sides, no problemo, right? You have one cuvette that just has distilled water in it, and that's this one, okay? You put it in the middle sample holder with the frosted sides facing you and facing away from you, so that the clear sides are on the right and the left, because the light beam goes crosswise like this, okay? So you put the thing in the sample holder like that, close the hood, and press Cal. That says Cal, and you may hear it click. And then it should come up 0. Now you notice here it says ABS, that means absorbance. If it doesn't say absorbance, follow the instructions in the handout, use these up and down arrows, and make it say absorbance, okay? It should also say 885 nanometers, just like it does, okay? If it doesn't say 885, again, follow the procedure and make it say 885. This little arrow right here, you see that little arrow right there, should point to ABS, not %T or conts, okay? But anyway, so now you've put the distilled water cuvette in, you've pushed Cal, now it should come up with, say, zeros. In a moment, there it is. Now you take another cuvette, the empty cuvette, and you take the first vial and you pour it in here. Now I've done this already in one, so I've waited the 15 minutes, but you'd be pouring out of these vials, not this little beaker. It's just for... Now this is a highly concentrated sample, and can you see kind of a blue color if I put it over white? It's kind of a faint blue, okay? Anyway, so once you've zeroed it, you take the distilled water cuvette out and you put the sample cuvette in again the same way, close the cover, and read it. So this reads 0.155, okay? So you write down the concentration, whatever the concentration in the vial was, and then next to it the absorbance, in this case like it'd be 1.155, and then you just go ahead, take your sample cuvette out, pour it out into the big slop beaker, shake it, take your next sample, pour it in here, and then, and this is important, before you put the sample cuvette in, put the distilled water cuvette back in, push cal. You zero it between each sample. So now it's going to say 0. Take the distilled water cuvette out, put your cuvette with the next sample from your standard curve in, read it. Okay? When you read it, then you just keep doing that. You alternate between the distilled water and the sample. And then you just take this sample out, pour it out. I didn't have anything in there to begin with. And go to your next sample until you've read them all, right? Then you also read the unknowns, okay? And that's basically the laboratory part of this. Then you follow the procedure in the handout to construct the standard curve to get the equation of the line using the regression. Your standard curve should have 2 points at each concentration. Now they might be the same number. They might look like 1 point, but you should have 2 values at each of the concentrations that you measure, and then you follow the procedure to get the answer for the unknowns. This is not the way to do a standard curve. You notice this is done with a line plot, and if you use a line plot, it'll give you that zigzag. You be sure to use an XY plot or a scatter plot if you do this with Excel or a spreadsheet. And that's the protocol. Be sure to put the phosphate reagent and the 600 micromolar standard, these two, back in the refrigerator. Okay? Then if nobody else is waiting, turn the instrument off, and that's it. Oh, I'm sorry. When you're done with all these vials, wash them out, give them pour them out, of course, give each one of them a little squirt of deionized water, like this, dump it, another little squirt, dump it, and then leave them upside down in this styrofoam box lined up in the same order that they are here, okay? And that's it. Okay, so